Welcome. In this channel, I will analyze and explain structural calculations for construction projects, focusing on sheet pile structures, to help you understand safe and effective engineering design. Sheet pile walls are structural elements commonly used in construction to support soil and control water. They are widely applied in projects such as river embankments, foundations, ports, basements, and excavation works. Sheet pile walls function as retaining structures that prevent soil movement and water infiltration, ensuring stability and safety during construction. Understanding the basic concept, function, and application of sheet pile walls is important for engineers and construction practitioners to design safe and effective structures. Sheet pile walls are commonly constructed using two main types of materials: precast concrete and steel. Each material has different characteristics, performance, and applications depending on the project requirements, environmental conditions, and structural demands. Precast concrete sheet piles are manufactured in factories and transported to the construction site. They are typically used in projects that require high durability, corrosion resistance, and long service life. Steel sheet piles, on the other hand, are made of steel sections and are widely used due to their high strength, flexibility, and ease of installation. They are especially suitable for deep excavations and temporary structures. Steel sheet piles are convenient to use because of their resistance to the high driving stress that is developed when they are being driven into hard soils. Steel sheet piles are also lightweight and reusable. Sheet pile walls may be divided into two basic categories: A. Cantilever sheet pile walls. B. Anchored sheet pile walls. Cantilever sheet pile walls are usually recommended for walls of moderate height, about 6 meters or less, measured above the dredge line. In such walls, the sheet piles act as a wide cantilever beam above the dredge line. Cantilever sheet pile walls are appropriate for simple construction projects and shallow excavations with low structural demands. However, they are limited in stability, excavation depth, and load capacity. When the height of the backfill material behind a cantilever sheet pile wall exceeds about 6 meters, tying the wall near the top to anchor plates, anchor walls, or anchor piles becomes more economical. This type of construction is referred to as anchored sheet pile wall or an anchored bulkhead. Anchors minimize the depth of penetration required by the sheet piles and also reduce the cross-sectional area and weight of the sheet piles needed for construction. However, the tie rods and anchors must be carefully designed. The two basic methods of designing anchored sheet pile walls are: A. The free earth support method. B. The fixed earth support method. The free earth support method involves a minimum penetration depth. Below the dredge line, no pivot point exists for the static system. The nature of the variation of the bending moment with depth for both methods is also shown in figure. Note that the free earth depth is less than the fixed earth depth. This means that the embedment depth in the free earth support method is smaller than in the fixed earth support method. In free earth support, the bottom end of the sheet pile is assumed to be free to rotate. There is no fixity moment at the base, and its behavior is similar to a beam with a pin support. As a result, the required embedment depth is shorter. In contrast, in fixed earth support, the bottom end of the sheet pile is assumed to be fixed. There is a resisting moment at the soil base, and its behavior is similar to a fixed-end beam. Consequently, a deeper embedment depth is required so that the soil can provide the resisting moment. First, we will analyze cantilever sheet pile walls, specifically the case of cantilever sheet piling penetrating sandy soils. This represents the general condition or standard method for homogeneous sandy soil layers. For other conditions, the analysis uses special cases for cantilever walls penetrating a sandy soil, which apply to non-homogeneous or more complex sandy soil conditions. As an example, we will demonstrate how to calculate a cantilever sheet pile wall embedded in granular soil. In this case, L1 equals 2 meters, L2 equals 3 meters, gamma equals 15.9 knots per cubic meter, gamma sat equals 19.33 knots per cubic meter, and the angle of internal friction equals 32 degrees. So, what is the theoretical depth of embedment, D? For a 30% increase in D, what should be the total length of the sheet piles? Step-by-step procedure for obtaining the pressure diagram. Based on the preceding theory, The pressure diagram for a cantilever sheet pile wall embedded in granular soil can be obtained by following steps 1 through 13 below. Thus, we can determine the embedment depth, d, and obtain the total required sheet pile length. We can then calculate the maximum bending moment and use this value to determine the required section modulus of the sheet pile per unit length of the structure.